Good morning, everyone. Welcome to Winter 2020 Climate and Water Update webinar. For those joining us for the first time, welcome. And for anyone who has joined us for our webinars before, welcome back. Today, we'll be giving you an in-depth analysis of recent conditions as well as temperature, rainfall, and streamflow outlooks for winter. My name is Jordan, and I'll be your moderator today. I am joined by Claire, who will be producing today's webinar. Together, we will help make the webinar as interactive as possible. But before we start, may I ask for your attention as we cover off some housekeeping items. With the current situation as it is in Australia, this webinar will be conducted from our respective homes. Please bear this in mind as we may encounter some technical issues during the broadcast. Our broadcast today will run for 60 minutes with plenty of time allocated for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time attendees, please see some helpful tips on your screen. Most importantly, please note the chat box, where you can send through any questions or feedback for the presenters. Please use this and not the Q&A box to send your questions to us during the session, and we will get to as many as possible during the allocated breaks. It is the speech bubble button in the taskbar on your screen. The icon will turn blue when it's on, so you know that you're chatting with us. If you want to test out the chat box now, feel free to tell us your name and where you're dialing in from. I know we had someone from Brazil today. In response to feedback received from previous webinars, here is some information on how to participate in our polls. When a poll is in motion, you'll see a set of questions on the right of the webinar screen. Please select your choice, followed by the submit button below them. I'll also take this moment to thank those of you who sent in questions during the registration process. We've developed the content of this session in accordance with the common themes of those questions, so thanks for engaging with us. And finally, I'm delighted to introduce you to our presenters, Robin Jewell and Jonathan Pollock. Hi, guys.
Hello.
Good morning, Jordan.
Robin has a strong interest in helping people understand complex science by finding new ways to interpret and make climate science understandable to all Australians. She has worked as a weather forecaster for the Bureau in Darwin and for the UK Met Office in England, so plenty of experience with winter. Jonathan joined the Bureau as a weather observer, collecting and recording meteorological data for climate forecasting and aviation purposes. Later, he moved into climate information services, turning data into useful information for agricultural, emergency services, and general public users. So, to the best here today. Welcome all. Robin, would you like to tell us what we'll be hearing about today?
So we're going to cover three main topics today, and we'll intersperse these with plenty of time for questions. We're going to start with a look at what's happened in autumn, so a bit of a wrap up of where we are right now before we head into winter. Then Jonathan's going to take us ahead and look at what we can expect in the coming months. And finally, we'll spend a little bit of time going into the detail of why the outlook is the way it is and what's influencing and driving the rainfall and temperature patterns we may see as we move into winter. I believe we're going to start with a poll, Jordan.
Yeah, we're going to kick it off before we get stuck into the talk. We'd like to know how autumn was for you. So what was it like where you live? A, warmer than average, B, cooler than average, or C, average? And while everyone's getting their answers together for that, you should see it on the right-hand side. We do have some questions that have come in. Ron is jumping the gun a little bit. Winter only just started, and his question is, why is it so cold this winter? Robin, I believe you might have an answer for that.
Well, it does feel a little bit like winter came early this year, especially if you're in the southeast of the country or the east of the country. So May was particularly cold, colder than average. We've seen a bit more cloud and rain than usual down south, and so with that cloud, that gives us that's less sunshine. So we get those cooler days when we have more cloud, and so part of this cloud and rain has been coming from more fronts and troughs. So that means we've had more cold air brought up from the Southern Ocean there over the top of us as well. So yes, it has felt like winter came a little bit earlier than usual this year.
Yeah, it definitely does in my household. We're already got the slippers out and the big jumpers. I hope I'm saying this name right, but Tergenza, I'm sorry if I've gotten your name wrong there, wants to know, what is the flooding outlook for Victoria over the next few months? Jonathan, you're the best person to ask about that.
Thanks, Jordan. Well, I don't want to spoil the rest of the webinar, but as Robin just mentioned, we had a pretty wet autumn across Victoria, and soil moisture is very high across parts of the state. So that increases the chances of flooding. But we'll talk a bit later about flooding because it's something that we generally see in most winter seasons.
Okay. Andrew has followed it up with a question for Robin. What's the likely forecast for Victorian and New South Wales ski season?
Oh, that's a really good question. So skis, it's very, everyone's really wanting to know that, I think. Snow is very difficult to forecast. It can be very variable, and we can just get one or two really good dumps at the right time, and that can set us up for a ski season in Australia. And also in Australia, it's not always about the natural snow anymore because we have a very big capacity to make snow. But we'll go into a bit more detail about what's happening in the oceans around us and how that'll influence what's going to happen this winter. But the short of it is, in terms of natural snow, we could be looking at average to above average falls. But the big caveat here is what happens with temperature. So we may be expecting more rainfall at times during winter, but if it's too warm, it tends to fall as rain instead of snow. So that's the thing that we need to keep an eye out for this year, but we'll give a little bit more detail on that as we move through the slides today.
Okay. Hope I'm not jumping the gun here either. Permata wants to know if it's going to be a dry winter or a moist winter.
That's a good question as well. So I think we're talking in terms of, well, we'll give the rainfall, it's going to depend significantly on where you live. So Jonathan will give the rainfall outlook. But if that question was more around humidity or dryness, again, we're going to talk about La Nina a little bit later. And if we do get a La Nina-like pattern, that increases the chance of rain at times during winter, and that can be associated with more humid winters as well.
Okay. We have had a couple of questions that have come through, like Jackie, who's asked for a seasonal and longer term forecast. Now, we don't know where Jackie lives, so if someone wanted to find that information, where would they go to on our website?
Definitely head to our website, and today we're talking quite broadly across the whole country, but we know most people want to know what's going to happen where they live. So we'll have links at the end, and on our website we do have the ability for you to pan and zoom and click right into your location and get a lot more information that's relevant just to your location. So
Okay.
copy down the links at the end.
Excellent. And those links will also be sent in an email as well to anybody who's attending today's webinar. All right, so our poll results are in, and most people believe that autumn was warmer than average. I wonder if the numbers bear out. We'll find out in a couple of minutes, but we are going to have another Q&A session coming up. So if you've got a question that you'd like to get answered, just like we had then, start sending it in the chat box now, and we'll get to it in the allocated breaks. Robin, you're going to give us the autumn wrap-up first.
Yes, I will start with the wrap-up, and I'll start with temperature, so we can have a look at that poll in more detail and have a think about this might show why we had varied answers, for example, because it depends very much on where you lived as to what sort of temperatures you experienced this autumn. So we're starting with daytime temperatures here, and the large map here shows the average across all of autumn. And so we can see if you lived in the north and the west, overall temperatures were above average. And this was particularly the case in Western Australia, and particularly in April. So in April, Perth reached 39.5 degrees on the 11th of April, and that was Perth's warmest April day on record. And later in that month, in the Pilbara at Mandurah, Australia saw its latest 42-degree day on record recorded for the end of summer. So that was very much a warm feature of our climate during April this year. But in contrast, if we look down in the southeast of the country, and in particular to the west of the divide, to the east of the divide, temperatures were closer to average, but to the west, temperatures were very much below average, and in particular in New South Wales. New South Wales saw its coolest autumn days since 1995. The little map there I've put is for May, because I wanted to point out that May in particular for large parts of the country was cooler than average. So Queensland on the 23rd of May saw its coldest May day on record. And a little bit earlier on the 22nd, Australia as a whole had its coolest May day since 2004. So that first question we got at the start of the webinar was very pertinent, because we have seen winter type temperatures start a little bit earlier this year. If we turn now to look at overnight temperatures, we see some similarities with across parts of the north and the west, seeing warmer nights than usual, like we did with days, and also the little map there shows May, and May will cool for overnight temperatures as well. But overall, in large parts of eastern Australia, with Tasmania being the exception there, temperatures averaged out to be pretty close to the long-term average overnight. We take a look now at rainfall. If we the big blue area over the Pilbara and follow that through the NT and down through Queensland and New South Wales, that shows the clear track that ex-tropical cyclone Esther took in early March, bringing really heavy and widespread rainfall across there, that part of the country. But if we move further into the southeast and Victoria and Tasmania there, we also see that we had above average rainfall there. So in the southeast, we saw more rain-bearing troughs and fronts spread across the seasons, particularly in March and April, than we usually do at this time of year. So Tasmania, in fact, had its wettest autumn since 1975, and Victoria since 1989. So that was a significantly wet autumn and also start to the year for many of these locations. But in contrast, if we look at Western Australia, central and southern areas there, rainfall was below to very much below average. So in central areas, some locations saw their driest autumn on record. Now, we did in the last, just recently, see quite a big event with ex-tropical cyclone Manga coming down the coast there and bringing around 50 to 80 millimetres of rainfall and some damaging winds and sand and dust and high seas. So we saw a significant event there, but it wasn't enough to lift rainfall totals across the whole season to their average. So another notable exception as well for dry conditions was southeast Queensland there and the far north coast of New South Wales, which saw a dry end to their summer wet season there. So it's very mixed across the country for rainfall. Like we saw with temperature, it was a mixed mix, so it depended where you were to what you experienced. Turn to soil moisture for May, the most recent map that we have here. This very much reflects the rainfall that we've seen through autumn. So in the southeast, where we've seen much more rainfall than we typically would at this time of the year, soil moisture there is above to very much above average, which is a significant change to what this part of the country has seen over the last 3 years. So for the first time in a long time, we're seeing streams and rivers start to flow again in the Murray-Darling Basin west of the Great Dividing Range there. As well, in contrast, we're seeing that relatively dry conditions reflected in lower than usual soil moisture in parts of Western Australia there. So it's been a very different start to the year in the agricultural regions of Western Australia as it has in Southeast Australia. Now, on that topic of again and rivers running, let's take a look at water storages around the country. A very busy map here, but the thing that struck me first when I looked at the levels of our storages around the country is that in absolute terms they're still quite low. So most of our storages are below 50% here in this map, with the exception of in Tasmania and the northeast coast up there, which are a bit above 50%. But in absolute terms, most storages are quite low. If we first across the north and west of the country, that little red line in the buckets shows where we were this time last year. So for these storages, the levels that we are now are lower than what they were at this time last year. So in the north, that reflects low rainfall, a poor wet season that we experienced in the north this year, and in the southwest there, where we haven't seen the infill start yet. So this is the start of the infill season in Western Australia there in the south, and we haven't seen those infills start yet. We haven't seen as much rainfall there as we have in other parts of the country. Most of the storages in the southeast there are all now at higher levels than they were at this time last year. And this time last year, some of these levels were incredibly low. So in the Northern Murray-Darling Basin, I think towards the end of 2019, levels dropped below 8%. So this very wet start to the year that we've seen has seen some very, very valuable inflows into our water storages in parts of the east and southeast of the country. But in absolute terms, they're still relatively low. And to have a look at the reasons for this, or a reminder, because many people, it'll be on the top of their mind, the very dry and drought conditions that we've seen in Eastern Australia in the past 3 years. If we do take a look at the longer picture, I've shown the year to date in the little map. So year to date, we've seen a lot of rainfall across large parts of the country, more than we usually would. But if we look at that in the context of the last 3 years, and that includes the most recent period, we still see a lot less rainfall, in some cases lowest on record, very much below average rainfall falling across that longer 3+ year period. We've seen with the soil moisture that if your operations depend on, for example, rain-fed pasture or crops, that you can see a recovery quite quickly with a very good season. So we've had a very good wet season, wet autumn in the southeast, and that's brought that soil moisture right up. But if your operations are more depending on how much water we have in our storages and deep groundwater, that's going to take a lot longer to recover than we will see pasture and soil moisture recover. So for our water storages to be replenished after 3 long dry years, it's expected that will take several seasons of average to above average rainfall for us to see those water storage levels return. But on that note, I think I'll hand across to Jonathan now, so that we can start looking forward to see what we can expect happen with rainfall over these and temperature over these next few months.
Thanks, Robin. So now we've got the winter outlook, and it's been an exciting week in seasonal forecasting. A lot of you, I hope, realise that we release weekly updates for the seasonal and the monthly outlooks now. And there's been a bit of a shift in the outlook from winter compared to last week. And before we look at winter, I thought it might help explain the story if we look at the first 2 months, June and July. So on this slide, we have 2 rainfall outlook maps, June on the left, July on the right. Areas of yellow or brown shading that indicate sort of below average rainfall is likely, and areas of green or blue indicate above average rainfall is likely. And those places that are white or beige have roughly equal chance of being wetter or drier than average. Now keep in mind that it's Northern Australia's dry season, and most of the north doesn't typically get a lot of rainfall at this time of year. The map for June is showing us that it's likely to be drier than average over most of southern and northern Western Australia, along with most of the Northern Territory, South Australia and Victoria, as well as parts of New South Wales and Tasmania and the northern tip of Queensland. The map for July is showing us that it's likely to be wetter than average across most of southern Australia, but most of Victoria and Tasmania and the New South Wales coast have roughly equal chances of being wetter or drier in July. So past accuracy for June is very high for parts of Western Australia, but it's very low for most of the Northern Territory and South Australia, extending into the eastern states. And the east coast is a mixture of very low to moderate past accuracy. But the past accuracy for July, that's generally better in Central and Eastern Australia than the past accuracy for June. And you can see the past accuracy maps for all of our outlooks on the Bureau's website. Now I'll show you the outlook map for winter. So the map for winter is showing us that overall, it's likely to be wetter in patches across Western Australia, Northeast and South Australia, far southern Queensland, and Western and Northeastern New South Wales. At the same time, the northern tip of Queensland and some coastal parts of Victoria and South Australia, along with much of Tasmania, but especially northern Tasmania, are likely to be drier than average this winter. And the rest of the country doesn't have a strong push either way. For winter overall, the past accuracy is very high for much of Western Australia and moderate or better for most of the NT and Queensland away from the Gulf. It's also moderate or better for northeastern New South Wales, but it's patchy for other parts of the southeast. And now we'll have a look at the temperature outlook. So on this slide, we have the maximum temperature outlook map on the left and the minimum temperature outlook map on the right, and they're both for winter. So areas that are pink or red, that indicates above average temperatures are likely. And the areas that are white or beige have roughly equal chance of being warmer or cooler than average. Now, the map for maximum temperatures is showing us that Northern Australia is very likely to have a warmer than average days, with above 80% chance in most areas. Further south, much of Australia is still likely to be warmer, but southern South Australia, southwestern New South Wales, and southern and western Victoria have a more neutral outlook for daytime temperatures. The map for minimum temperatures is showing us that most of Western Australia, except the southwest or the far southwest, and most of Queensland, along with parts of the Northern Territory and northeastern New South Wales, are very likely to have warmer than average nights. Those areas generally have chances above 80%. And most of the rest of the country too is also likely to be warmer than average, with chances above 60%. But southern South Australia, southern and western Victoria, and northern Tasmania have roughly equal chance of warmer or cooler than average nights. The past accuracy for the maximum temperature outlook for winter is moderate or better across most of the country. And the past accuracy for minimum temperature outlooks for winter is very high over parts of Western Australia and most of the Northern Territory and Northern Queensland. But it's low for the southwest tip of Western Australia, and it's pretty low around Adelaide and northwestern Victoria too. Now we'll have a look at the stream flow outlook. So the map on this slide shows the stream flow outlook for sites around the country, and the outlook is for May to July. Sites that are shaded yellow are likely to have lower than average flows. Sites shaded light blue are likely to have near median flows, and sites shaded dark blue are likely to have high stream flows. Now there's another category though, there's sites that are shaded grey and they're labelled normal flow in the legend. And those are sites where you've got close to an equal chance of either low, near median, or high category stream flow. And what this map is showing us is that it's mostly high stream flows that are likely from May to July in the southeast. You'll notice there's a concentration of dark blue high flow sites in northern Tasmania and through Victoria and New South Wales. Now, during April, most sites across Australia had low or near median flows, but parts of the southeast did have high flows. So stream flows have been a bit mixed across Australia, and the outlook map on this slide is showing us that that is likely to continue. We'll have a look now about at some types of significant weather that we often get during winter. And winter often brings with it the chance of riverine flooding, frosts and storms and flash flooding. Rainfall and soil moisture are key factors in those types of significant weather. And while the outlook isn't showing a really strong push towards a wetter or drier season for most of the country, as Robin showed us before, overall it was a wet autumn for most of southeastern Australia. We've already had a flood warning in Victoria this week. And even though nights are likely to be warmer than average this winter, we're still heading into the coolest time of the year, and most of the southeast still has the potential for some frost events. We've even got frost on tomorrow's forecast for the hills around Melbourne. Winter storm surges on the southern and eastern coast exacerbate sea level rise, making coastal flooding and erosion more likely. And you can keep up to date with the latest watches, warnings and alerts on the Bureau's webpage.
Excellent. Thank you for all your information there, guys. We do have another poll there and some more questions to get to. So the poll question is, what climate sensitive decisions are you making this winter? So is it decisions for A, agriculture, B, water management, C, emergency management planning, or D, what are these decisions or other sectors? Please tell us. While we get those in, and you'll see the poll up on the side now, we do have some questions to get to. Steve would like to know, what is driving the East Coast outlook as being so different from the rest of Australia? Robin, I think that's something you can answer.
Yes, well, I'm going to go into a lot more detail soon, and we're going to take a really close look at what's happening in the Pacific Ocean and the Indian Ocean.
Okay.
But I guess the short story is that we are seeing some signs of a La Nina-like pattern developing, and that can increase the chance of rainfall in Eastern Australia. And it tends to really only be an influence to Eastern Australia, not Western Australia.
Okay, so more on the climate drivers a little bit later after this, and we've got plenty of questions coming up about the all different climate drivers that are affecting Australia right now. Janie would like to know, how is soil moisture measured?
Oh, that's a really good question. So there's a couple. Soil and moisture, if you're at the location, you can just kick the ground and you can have a look yourself. But we also rely on probes, so you can put probes into the ground, which will also take a more formal measurement. But because we don't have probes everywhere across our country, we use a modelled approach as well, to give us to fill in those gaps that we have. So if you know what water's going in and you know about the properties of the soil and how that changes across the country, we can model what soil and moisture is at locations. So it's quite complicated, actually.
Yeah, okay. So Lachlan seems to be a big follower of all things Bureau. He said there was a significant change in the 3-monthly outlook from the 14th of May to the 28th of May. Now, previously there was an above 80% chance of a wetter than average, than it being wetter than average across much of the country, and this probability has dropped considerably. What changed this, Jonathan?
Well, we've seen some big changes in the eastern tropical Indian Ocean in the last couple of weeks, and that's really been the driver for the change in the forecast. And so, what was looking like a wet winter for a lot of Australia is now looking more neutral. We just had a look at that winter outlook map, and there was a lot of white on there, so not a strong push either way for a lot of the country. But if you remember when we were looking at the monthly maps. So we're still expecting some above average rainfall to come. It just looks like it's going to come later in the season now. So it looks like there's not much of a wet signal for June. And in fact, June's likely to be drier for a lot of the country. But by the time we get into July, we're starting to see that wet signal appear again. And we've got increased chances of above average rainfall for much of southern Australia.
Okay. Interesting. So I know we don't want to touch too much on what is happening with the IOD and Indian Ocean Dipole and also La Nina, some of those other things that we will be covering soon. But I did want to start with this question. Looking at potential high rain, how strong will the IOD be this year? Will it be aided or impeded by other drivers? Again, I know you're going to talk about this soon, Robin, but I just wanted to ask that little question from Susan first.
That is a really complicated question to answer. At the moment, we're trying to determine which way the ocean's going to go. And at this time of the year, we call it a bit of a predictability barrier. So this is the time of the year that it is most challenging to tell which way it's sort of a period where the oceans reset themselves, both the Indian and the Pacific Ocean. And so when we look in more detail, I'll explain why. At the moment, we're not sure whether we're going to go into neutral or negative, and there is still an outlying possibility of a positive there. But when we get into June and July, the ability to look ahead, our climate model's ability to look ahead, the accuracy improves significantly. So this is something we watch really closely right now, and we're entering the end of the predictability barrier period. So as we go into June or July, that's when we can see which way things are going to go more clearly, and then how strongly they're going to go in that direction. So it's a little bit early to be too conclusive right now.
Okay, fair enough. I'm sorry. You can tell I'm not an expert, because to me that seems like a little question, but then the answer's pretty large, and we'll get all into your IOD and climate driver questions in a little bit after we talk more about the climate drivers soon. But just wanted to ask one other question. Vedana wants to know, why does the past accuracy in rainfall vary across the country?
Because the essentially rainfall is more or less predictable at different times of the year in different regions of the country. So Robin was just talking about an autumn predictability barrier. So often past accuracy will be lower for regions of Australia at this time of the year. But then in a few months' time, what can happen often is that you'll get the either La Nina or El Nino events out in the Pacific, or or negative or positive Indian Ocean dipole events out in the Indian Ocean. And when they start up, they sort of start a feedback cycle, and they'll lock into phase for several months. And if something like that does happen, that gives us a lot more predictability. So areas that have a strong influence from those types of events can tend to have better accuracy in the times of year when they're around.
Okay. Well, plenty more climate driver chat coming up just after this, but the results of our poll are in, and most people, their climate sensitive decisions are being made around agriculture. And we have had a couple of people also message us with different ones that they're looking at: electricity markets, building and construction, floodplain risk management. So thank you very much for getting in your opinions there. We're going to move on now to the climate drivers. Remember, we do have more time for questions, so keep them coming in. The last Q&A session is coming up towards the end of the webinar, but Robin, you're going to tell us about the drivers affecting Australia's weather.
Yeah, it's very timely. I see we've got lots of questions, so hopefully I can start answering these questions. So there are a lot of things that impact the weather and climate in Australia, but when we're looking on the longer time scale, so for the months and seasons ahead, we look really closely at what's happening in our oceans around us, because that tends to, what's happening with the temperature of the ocean can push our climate towards wetter or drier or warmer or cooler. So today I'm going to focus on looking at the Pacific Ocean, so El Nino and La Nina. We're going to take a look at what's going on in the Indian Ocean dipole, and we're also going to look down towards the Southern Ocean and look at what happens above the Southern Ocean, and we're going to look at the Southern Annular Mode. So I'm going to start to our east, looking at the Pacific Ocean. So many of you would be quite familiar with El Nino, which is what brings us our dry and drought conditions in Australia. The El Nino Southern Oscillation is made up of three phases: El Nino, Neutral, and La Nina. So the opposite phase to El Nino, La Nina, is shown here. And during a La Nina, what we typically see is cooler than usual water develop over the central and eastern Pacific, and we have warmer than usual water develop near Australia. Where that ocean is warmer than usual, we have more air rising, which means we have more cloud and more rain. And that air that comes up, it must come down. And in this situation, the air tends to subside over that cooler region. And this sets up a little bit of a circulation pattern where that air then gets sucked back towards the warmer water, and we get stronger trades, and that pushes more warmer water to Australia, and it allows more cold water to upwell from the deep in the other side of the ocean. And so when this system sets up, the ocean and the atmosphere feed back on each other and they strengthen each other. So El Nino or La Nina are usually an autumn to autumn feature. So they can start to develop through autumn and winter. The events usually peak towards the end of the year and they usually decay in the first part of the following year. So if we take a look at right now in the Pacific Ocean, if we look along the equator there, we can see that there is some blue areas, so some cooler than usual water that's developed along the surface there in the central and all the way along to the eastern Pacific there near South America. If we looked below the surface, which I haven't got here, but below the surface there is a very large volume of cool water which is floating up towards the surface at the moment. So we expect that we're going to see more of those blue areas appear, more cooler than usual water appear over the coming weeks. What we do notice though is if you look at that schematic is we're just seeing tiny weak signals here. This pattern right now doesn't look strong pattern we see in the schematic there. But we do look very closely at this particular region here that's in this box. And its technical name, this region's technical name is Nino 3.4. We look very closely at the temperature in this box because it can be a very good indicator of whether we'll see a La Nina or El Nino develop. So on the next slide, I'm going to show a graph of what we expect will happen to the ocean temperature in this region. This shows that the solid line shows what has been happening and the green line shows forecast. So we can see here that the Bureau's model forecasts the temperature in this region, in this central part of the Pacific, that it will cool, and it will cool towards that blue line. So that blue line there is a threshold. Once we get temperatures below that threshold, that's when we generally see that circulation pattern able to develop over the top of the ocean, which causes that feedback, which causes the system to fully develop and strengthen. But we don't want to get too stuck on thresholds because it's not an on-off switch. So approaching the threshold, when we approach the threshold, we can still see some La Nina-like in our atmosphere. At the Bureau, we don't just look at our model, we do take a look at what other models around the world are forecasting because some other centres have some excellent models as well. If we take a look at other models, so the Bureau's model is on the top. This is the forecast for that region of ocean in the centre there for August, so the end of winter. We also look at a Canadian, European, Japanese, French, a couple of American models and a UK model. And what we see here is that models are forecasting that the ocean is likely to be cooler than average by the end of winter, but to differing degrees. None of the models forecast that by the end of winter, we will have reached or exceeded that threshold of where we see that feedback system start. If we look a bit further ahead though into spring, we start to see that some of the models, 3 of the bureaus start to reach or exceed that threshold, but other models approach that threshold. And it's not an on-off switch, so let's remember that. But at the moment, because still, even in winter, we're still seeing most models below or most models not exceeding that threshold, our outlook at the moment remains inactive. So that means we're seeing it's a slightly less than 50% chance that will go into La Nina. To meet the watch criteria, which means it then becomes a 50% chance, we'd need to see a little bit more certainty in the models. But as I touched on before, this time of the year is the time of the year which models struggle the most to forecast what's going to happen in the Pacific Ocean. So this is something we watch really, really, really closely. And it is possible that we could meet that watch criteria in the coming weeks. So we update our outlook status on Tuesdays, every second Tuesday. And the next time we do that will be next Tuesday. So the link at the bottom there will take you to our ENSO wrap-up. You're also able to subscribe to this product so you can get an e-alert if you want to get a message when the product is updated. And I would highly recommend keeping an eye on this as we move into that period where we get very much more skillful at forecasting what's going to happen, it becomes easier to forecast in June and July. If we do go into La Nina, or if we approach that threshold and get La Nina-like conditions, these maps here show how that typically influences Australia's climate during winter and spring. So that's temperature on the left and that's rainfall on the right. So we often see cooler days and we often typically see wetter conditions. So we are seeing, especially in July, a signal in our model of wetter conditions, and a large part of that signal is coming from this forecast that our model is seeing of us approaching or potentially exceeding La Nina conditions in the Pacific Ocean there. It can also increase our chance of widespread flooding. That's one of the significant weather type things that we see during La Nina. So we're keeping a very close eye on the Pacific at the moment. But if we do turn now to take a look at we have a similar phenomena which happens in the Indian Ocean called the Indian Ocean Dipole. And the phase that we're looking at today is the negative Indian Ocean Dipole, and that looks similar, doesn't it, with warm water near Australia and cool water over near Africa. One of the main differences in the way that the Indian Ocean Dipole acts compared to El Nino and La Nina is that they're shorter lived. So Indian Ocean Dipole events are winter and spring phenomena. And this is because the monsoon trough just naturally behaves differently in the Indian Ocean than it does in the Pacific Ocean. So in the Indian Ocean, we have a strong trough every year, which will come into the Southern Hemisphere in the last months of the year and shuts that circulation off. And so usually Indian Ocean dipole events don't go into the next year like El Nino and La Nina events can. If we take a look at what's happening right now in the Indian Ocean, shows the sea surface temperature anomaly, how it's different from average. We actually see a lot of red on that map. So a large part of the Indian Ocean is warmer than average. We have two key regions, like we have a key region in the Pacific that we watch. And if we look in these regions here, we're not seeing a pattern that looks like that schematic yet. Unlike in the Pacific Ocean, where we are seeing some early signs in the observations, we're not seeing anything yet that is leading us to think that we'll get a negative Indian Ocean dipole. And if we take a look at what's happening in these two boxes, in this case, we take a difference between the two boxes, one box minus the other box, to give us an index. And if it's more positive, that means we're seeing cool water near Australia. And if it's more negative, warm water near Australia. So if we have a look at our model forecast, I notice about this forecast, which is different to what we saw in the forecast in the Pacific, is these little grey lines. So these grey lines around the green forecast there show all of the different possible scenarios that we could see. So it's like our cone of uncertainty. I didn't point it out when we looked at the Pacific, but that grey line was very much smaller around, that grey area was very small around the forecast. So in the Pacific, most of the outcomes were either sitting in the neutral or the La Nina. But here we notice a very big spread, which ranges between negative to neutral and even into positive. So this says that our model, there's uncertainty in our model forecast at the moment about what's going to happen. And as mentioned, that's common at this time of the year. And it's also much more prominent in the Indian Ocean than it is to the Pacific Ocean. So we have a lot more ability to forecast with accuracy what's happening in the Pacific than we do in the Indian Ocean. And it's the same with all models, not just the Bureau model. It's just a more difficult event to forecast physically. The good news is that we're moving out of that period and we're going into the period where skill rapidly increases. One thing we can do in this situation, though, is take a look at what other models are forecasting. August, so the end of winter, And we're looking at a range of other models that make these types of forecasts and what they're forecasting with the Bureau on top. And we can see now that the Bureau and the Canadian model are quite similar, but most models are forecasting a tilt towards a negative Indian Ocean dipole. Negative Indian Ocean dipoles do occur more frequently with La Nina, so it's important to keep that in mind. But on the flip side, it's important to keep in mind that all models struggle at this time of year. If we look further ahead into spring, we see a similar pattern with those models that are forecasting a negative IOD, mostly forecasting that to strengthen for the most part. Like with La Nina, the typical way that temperature and rainfall are influenced by a negative Indian Ocean dipole are shown here, with resulting in cooler days in the south, warmer days in the north, and an increased chance of rainfall over a larger part of the country. La Nina tends to be more an east of the country impact. You can see more of an influence in the western part of the country with a negative Indian Ocean dipole. But this is something that we need to keep a eye on as we move into June and July. And very finally, I think it's time now to start looking southwards at the Southern Ocean. So we're going to take another turn now and focus on a different part of the country. As we've touched on a few times already, something called the Southern Annular Mode. Now, to the south of Australia, we have our roaring 40s or our rain-bearing westerlies. And so in the wintertime, it's just normal for these to move, these rain-bearing westerlies to move northwards, and that's why we have a southern wet season in Australia. Our southern winter is when we get clipped by fronts and troughs that travel in these westerlies and give us our winter rain. In summertime, they move further south, and in Australia, we're dominated by high pressure in summer, and that's why we have fine and dry summers. But we do still see at any time of the year situations when these westerlies might sit a little bit more northwards or a little bit more southwards than usual. When they sit more southwards than usual, we call this a positive southern annular mode. At the moment, we do see, our model does see an indication that in June that we will see these westerlies sitting more southwards than usual. Now, one of the main differences between the southern annular mode and the Indian Ocean dipole and the La Nina, which I've talked about already, is the frequency of change of phase. So while in the Pacific, a La Nina is an autumn to autumn feature, and in the Indian Ocean, the IOD is a winter-spring feature, the southern annular mode can switch phases quite quickly between 1 week and the next week. So sometimes these phases don't last very long. Occasionally, we can get an idea of a trend that might occur across a whole season, but usually we can only see a few weeks in advance whether we're going to be in one phase or another. In a positive phase, you can see there typically at this time of the year, it makes it harder for those fronts and troughs to reach over Australia, and we see less rainfall. If we take a look at our June outlook that Jonathan showed earlier, but if we focus on this, so I'm just going to grey out the north there, because in the north it's the dry season. It's normal for us to get little or no rainfall. So a forecast of below average rainfall is not so meaningful. But in the south, when it is our wet season, we do see that in June in particular, we're seeing an indication that we'll see drier than usual conditions, which is very much a SAM-like something we would expect in a positive SAM situation. And as Jonathan touched on earlier, a week ago, we had a couple of weeks ago, that Indian Ocean was a lot warmer, and that was very much swamping this positive SAM influence. But now that that ocean cooled very quickly, this positive SAM is able to have a stronger influence on our outlook in June. So that outlook in June has changed quite a lot over the last week or so, whereas in July we're still seeing that La Nina-like influence coming in and giving us a wetter than usual outlook in July. But we are seeing an influence through June from a positive southern annular mode.
Sorry to cut in,
No,
Robin.
at all.
We're getting like quite a lot of questions, so I'm going to have to give you. If we were in the Oscars right now, the music would be playing. We're going to have to
Okay,
have to speed it
I'm
up just a little bit
finished.
so we can get to a bunch of questions.
All right, no worries. I'm on my last slide, but I think I've probably gone over it enough already. We're looking at potential La Nina in the Pacific, in the Indian Ocean. It's too early yet to know what's going to happen, but some models do forecast we could go to a negative IOD. Both of these increase the chance of rainfall across large parts of Australia, but in the shorter term, we do see that we may, in the south, see a positive SAM bring drier than usual conditions. Now hit me with those questions, Jordan.
Excellent, Robin. Thank you. I hope that's given you and your business a lot of information you can use to better plan for the upcoming months. And as I mentioned, we have gotten a lot of questions to come through, so we'll get to as many as we can. We might go over a few minutes, so hopefully we do get to your question as soon as possible. So many questions that have come in all about the IOD and the SAM and every other climate driver. But before we got to that, I thought I'd ask this one because a lot of people have brought this up. Now, this might be something that you won't be able to answer now. It might be something that is a future question. But Dwight, he's wanted to know, and quite a few people have asked this, with all the restrictions that COVID-19 because there's been decreased air and sea traffic, has that changed any of the models or any of the outlooks?
For the most part, when we look on the longer time scale, we are so strongly driven by what's happening in terms of the temperature and making a very big, and that has an influence in the way, you know, where it's warm, we've got that rising air. And so that sort of setup, which is our very big driver of what's going to happen, isn't impacted, no, by changes in air quality. So, so no, the answer is not really.
Okay, well, that satisfies as soon as I saw that question, I was like, of course, what would the answer be to that? David is wanting to know, is the pattern of dry/wet for autumn in correlation to La Nina or El Nino cycle? And I think you spoke a little bit about that.
It's related, so that wet signal that we're seeing there is related to La Nina.
Okay. With all the rain that we've had, Andy wants to know, is it looking better for drought-affected communities?
Yeah, as Robin showed, I think back in her slides, it's certainly been a huge improvement. The year-to-date rainfall this year is looking very different than the past couple of years. But on that longer-term scale, sort of the 3-year period, there still are areas across Eastern Australia that are very low or even lowest on record.
Okay, excellent. All right, so KS, they've put their name. They'd like to know, when was the last time we had a La Nina and a negative IOD combined?
So that would be, I think, 2002. It's hard to answer off the top of my head, sorry. We did have a very strong negative IOD that occurred in 2016, but it occurred alone. We didn't have its sister occurring in the Pacific Ocean. We did have a couple of years in a row where we experienced La Nina conditions between 2010 and 2012. And we did have a negative IOD occurring in 2010. But I believe we also had positive SAM at the same time, which also had negated that. We like to neatly put these drivers out separately and talk about them separately, but they all interact together and interfere with each other sometimes. Generally, when we have a negative IOD and a La Nina occur at the same time, it amplifies that response and it increases even more the chance that we'll see widespread flooding or increased rainfall and lower temperatures than when they occur separately. But sometimes that SAM gets in there as well with an opposing sort of influence too. So I hope I've got my history correct.
Well, speaking of history, and maybe I am putting you on a spot again, Dean has asked, taking into account all forecast models and patterns, is there a comparison year to 2020 that we can look at in the past?
I know it's really for comparison years, but by far the most accurate way to forecast what's going to happen in the future is using using modelling. So a dynamic model, which uses the laws of physics and chemistry to determine what's going to happen from what the current state of the planet is right now. So we can go back and you can look at analogues to see what's going to happen. But I would really strongly encourage looking at the computer models and the supercomputer calculations of what's expected to happen, because it'll look at all the different drivers and it's able to use those laws of maths and physics to work out which is going to be the strongest and most dominant.
Okay. Andrea would like to know, what drives the SAM up and down?
Oh, that's another.
Yeah, there's
Jonathan.
a relationship between SAM and the subtropical ridge. That a belt sort of high pressure that sort of spans across Australia and moves south with the seasons. There's a bit of sort of to and fro between those two drivers. That's one driver we didn't really touch on today, the subtropical ridge, but that can often sort of determine or can influence how far fronts and troughs can push further north as well.
Okay. Jonathan, might as well stay there since you've started. Sam would like to know if there's any fire weather outlook at the moment.
There should be a fire weather outlook issued soon. We don't have one at the moment, and there should be one coming out for Northern Australia soon.
Okay, great. Excellent. Lawrence has asked a question for you, Robin. Does a season with higher rainfall necessarily mean a season of lower freezing levels?
Not necessarily. No, it depends what temperature is going to do. So we can have situations, like if this is a snow related question, so yes, we can see if we have a season with a lot of rainfall and it's cold, we'll get a lot of snow, but it's not necessarily the case. We can definitely get seasons where we have above average rainfall, but that is also paired with warmer than usual temperatures. And that tends to, and in that case, then we see less snow. And that does tend to happen more often now because of global warming, and we just more often see temperatures being warmer than average. And it can also be related to what's going on with La Nina and El Nino, for example. And if you've got more warm water near Australia, that can sometimes mean that you'll have warmer temperatures as well, because the ocean near you is warm. And when we do have more cloud and rain, that also means that we have usually warmer overnight temperatures, because that cloud acts like a blanket. And so it can, we don't often fall to those really low temperatures that you do when the skies are clear. So no, it's not a simple way to answer that question. It depends on a lot of things and it can go both ways.
Okay. Ashley would like to know, do La Nina conditions increase the probability of above average cloudiness in Queensland and New South Wales?
They definitely do.
Okay. Great. That's probably the most straightforward answer we've had today. Stuart, is the lower chance of rainfall in Tasmania and coastal Victoria reflective of the impact of the IOD, resulting in decreasing chance of rain coming from weather systems south of Australia?
No, as Robin's sort of been showing you, it looks as though the wet signal that was on the outlook last week, that was being driven mostly by the Indian Ocean, and has sort of moved off, and now we've got this neutral outlook for a lot of the country. But for parts of southwestern Victoria and northern Tasmania, it's a drier outlook, and that's sort of, a lot of that signal is coming from June, and as Robin showed you, that's sort of an influence from SAM.
Okay. A lot of people asking about the spring frost or frost moving forward. Are we going to see increases in that, Robin?
It depends very much on your location and where you are. So in some parts of southern Australia, there's an increased chance of warmer nights, and so it reduces the chance of frost. And so our July forecast, for example, we're seeing in some locations an increased chance of rain. That means more cloud, and so that means that reduces the chance of frost because that means at night time that cloud acts as a blanket. But in June, for example, we're seeing an indication that in many locations that it'll be drier than usual. That means less cloud, and that means an increased chance of frost. So we're seeing quite a marked difference across the season in what we're going to expect, with the June outlook very different to the July outlook. And so that means that the outlook for frost is different as well with each month. But we do have so on our website, we'll have some links at the end. We do provide some more information. We have a frost outlook there so that you can go and check that if that's your interest.
Okay, so last question, Tim. Most farmers are too wet in Victoria at the moment with their tractors getting bogged, so he reckons a dry June could be a good thing. Do you have any forecasts or where someone can find these forecasts for September to November, or is that too far out?
The latest that we look ahead now is September. So we're presenting the outlook here. So we've just shown June, July, August. But on our website, you can see an outlook for July, August, September. Okay. And for large parts of the country, it's quite wet because that June has dropped. We dropped that June month out of that 3-month cycle. But it does vary depending on where you are. So we tend to get stuck on, we see this big lot of green across there, but please do go and check out your location, what the forecast is.
Okay. Well, thank you very much for everybody who sent in questions. We have run out of time, unfortunately. There's a lot of information to take in there. So if you missed the start, Jonathan, would you like to summarize what we spoke about today and where people can find out more information?
Yeah, thanks, Jordan. So the summary for winter 2020. Winter is likely to be wetter than average across patches of Western Australia, northeast and South Australia, far southern Queensland, and western and northeastern New South Wales. Now, the northern tip of Queensland and some coastal parts of Victoria and South Australia, along with much of Tasmania, but especially northern Tasmania, are likely to be drier than average this winter. And the rest of the country has no strong push either way. It is likely to be warmer than average during winter, especially across the north. And winter is a season when flooding and frost typically occurs. Now, for more information about what we've discussed today, the Outlook maps that we've looked at and more they're available from the Climate Outlook's webpage. And make sure you have a look at the Climate and Water Outlook video. It's a great summary of recent conditions and the outlook. The 3-month and 1-month streamflow forecasts are available from the link to our seasonal streamflow forecast page. The ENSO wrap-up is our fortnightly commentary on the current state of our climate drivers and what the models think might happen next. If you want to know more about flooding or severe thunderstorms, go to our Know Your Weather page, where we've brought together warning information and safety and preparation information into the one spot. We would like you to engage with us on social media using #BOMWebinars. And if you didn't get your questions today, if you didn't get your question answered today, I apologise, but please email us at helpdesk.climate@bom.gov.au and we'll try and get back to you as soon as we can.
Excellent. So plenty of information there, and those links will be part of a PDF that we send with the email with that has the video of this presentation. So our next BOM webinar, we're going to go where no webinar has gone before, space weather. What is it and what does it affect will be on the 14th of July. Did you know that the Bureau monitors for space weather and that things that happen way out in our solar system can affect power grids and communication systems? We're really excited about this one. So if you'd like to come along, then please click the registration link in the chat now so you can join us. That brings us to the end of the webinar today. For questions that we didn't get to, as Jonathan mentioned, helpdesk.climate@bom.gov.au. A big thank you to Robin and Jonathan for your time in developing the content and sharing your knowledge with us. And to you, thank you for tuning in and joining us today. We hope you enjoyed the session and we do hope you'll join us again next time. If you'd like to continue the conversation, please use the #BOMWebinars in your LinkedIn posts. As mentioned earlier, this session has been recorded and we'll have the video ready for your on-demand viewing pleasure in the next couple of days, so watch this space. Finally, but most importantly, we want your feedback. It's our aim to bring you the highest quality webinars, but we can't do that unless you share your experience with us. So once this webinar closes, a short survey will pop up on your screen, and we'd be very grateful if you could complete that anonymously for us. Once again, thank you for your time, and we look forward to seeing you again soon. Goodbye.